Welcome to Desk Ladyada.
Hi. Hello. It's Desk Ladyada. It's me, Ladyada. I've been working nonstop, but I thought we would stop the nonstop and maybe talk about some of the cool things that have been happening in the engineering that's going on. We have some new products coming out.
Can't stop signal.
No,
We're doing Desk Lady every single night, 24/7. We just turn on the camera once in a while.
Right. No, I'm always at my desk. I just don't always broadcast it. But we're kind of, slowly getting into it. We had a lot of good stuff going on behind the scenes.
Yeah, we've been fighting crime.
Yeah, we've been fighting crime.
Yeah, we're like vigilantes.
It's also nice out. So we go for little walks.
You know what's fun about bad people? You can hit them as hard as you want sometimes.
It's true.
And you don't feel bad about it.
Well, instead of talking about bad people, let's talk about good things. So one of the really cool things...
So,
what?
By the way, so Ladyada and I are watching the RoboCop trilogy. So...
and by watching, we watched the first one. And
by the way, Frank Miller co-wrote RoboCop too. Just some trivia. I'm throwing out. Okay, I'm just going to get back to the show. Sorry.
Do you want to say anything more about RoboCop?
No.
Okay. So some good news with stuff that's going on is we're cranking on CircuitPython. Scott, who's doing the main development on CircuitPython, is back in town. The dev boy is back in town. The boys are back in town. We played that today on the Alexa. And Alexa, play The Boys Are Back in Town.
No, don't do that because we're going to get clipped by... No, don't do it. Don't do it.
What?
No, we're going to get clipped by Content ID.
Why? They're playing it in their homes.
Oh, right. We turned off...
Yeah, this one doesn't... Yeah, that one doesn't use Alexa.
Yeah, we... Okay,
There's nothing in here that you can...
No, I'm just getting ready because I'm just like, wait.
No,
okay.
no, I wouldn't do it. No. We're never playing copyrighted music. Can I do it again then?
Do whatever you want.
Alexa, play The Boys Are Back in Town.
All
right, so now that you're listening to this awesome Thin Lizzy song, we're getting back to doing CircuitPython. We're finding some bugs and fixing them in the bootloader. Nothing beta tests like 250 people with like all sorts of crazy ass machines like Windows 10 laptops and like Chromebooks and stuff. But one thing that happened that was really neat is in the meantime, only a week or two ago, the UF2 bootloader was released, documentation and source code, and so this is really exciting. We'll do a blog post about this like any day now or hour now. But I thought I would talk about it because it's kind of interesting. So the UF2 bootloader, well, for people who've been watching Desk Ladyada for a really long time, you may have remembered I was working on the original Circuit Playground, the one with the at Mega 32U4, the one in the store. And one of the things I wanted to do is have a bootloader like the microbit, where it shows up as a disk drive and you drag a file onto it. This is one of my favorite kinds of bootloaders. The LPC 1343 has it built into ROM. It has a ROM mass storage bootloader, which is like really sweet. And the microbit has a little chip that does embed programming, acts like a mass storage device. And I really like that about the microbit because what's nice about mass storage bootloaders is you don't need drivers. You don't need an IDE. You don't need a special tool. You have a file, you drag. Everybody understands it's a USB key. You drag a file onto it. So they're really nice bootloaders. And I was trying to get the at Mega 32U4 working with a mass storage bootloader, and there is one in the Lufa core. So if you go to let me see if I can. There's like Lufa mass storage bootloader. So if you're personally interested in trying this out, so back in 2013, Dean Camera made a bootloader for the 32U4 that was like 8K of flash, and yeah, it looked like a disk drive and you could drag the file on. So cool thing about it is one, it actually works, but it only works really well in Windows. So I actually loaded it on. I tried it with Windows. I actually got it working even with our Arduino IDE, and I was like super psyched. And then we were like, okay, well, let's try it on Mac and Linux. And that's where things went south. So on Windows, and this is kind of low-level stuff, but when it copies a file, it does it in a very nice way where it like writes the beginning of the file, and then it goes byte till the end of the file. It's like completely the right way to do it. And then it updates the file system table. But when it writes the file, it writes it in order, and it writes it using the same sectors that it already uses. Linux doesn't do this. It like writes them to new sectors and then like changes the table. And Mac does this thing, and anyone who has a Mac knows this. It creates these like DS store trashfs file. It creates like 32 kilobytes of files. It just goes crazy. And all of that stuff confuses the bootloader, and so you end up having to do a lot of work to make it so that a mass storage bootloader written like this works well with all sorts of operating systems, because most of the bootloaders, to be efficient, they assume that when you start writing the file, you start at the beginning, like you start at address 0, and then you write the file bit by bit until you get to the very end. And that's how you bootload a microcontroller as well, so it works out quite well. You know, as you write the file, you bootload the microcontroller. So that worked quite well on Windows only, and so I kind of ended up ditching it and saying, like, you know what, that's not going to work out. For the Circuit Playground Express, I was like, okay, well, we actually have a shot of doing this because we have so much flash and so much RAM, and we also have that SPI flash chip. I'll show it because it's this little SPI flash chip here, which I was like, well, at the worst, we could have that show up as a disk drive, and they copy the file, and the bootloader detects it. Like, we had all these ideas of trickery of how to make it work, and I actually think it would have worked quite fine. But what happened is, as we were working on Circuit Playground, some really awesome folks from Microsoft were like, hey, wouldn't it be really neat if Circuit Playground had a mass storage bootloader and you could use it with MakeCode? And I said, yeah, that would be really cool. I just haven't written one, but if you had one, that would be pretty nice. And they're like, well, could you tell us what you want in it? And I was like, well, here's what it would do. And like 3 days later, they're like, oh yeah, we've written it. So they wrote a really, really nice bootloader for the SAMD processor series. And it solves this problem in a really, really cute way. So the problem, again, with most mass storage bootloaders is the bootloader assumes the file is going to come, starting at address 0 and then all the way to the end of the file. And every time it writes a byte, it will write that to flash. So it's kind of a one-to-one transfer. That doesn't always happen. Again, sometimes they get written out of order, which is extremely confusing. And the bootloader doesn't have time to figure out what's going on. So the really smart thing, and you can check this off at Microsoft/UF2, is instead of having the file be like a binary file, where byte 0 is the 0th byte and byte 200 is the 200th byte, they actually segment the file up, and every block of 512 bytes, and that's important because that's the block storage used for file systems, it's always 512 bytes. There's magic numbers, and it also tells you what address those bytes would go into. So instead of trying to figure out, I have this raw data, where does it go? Every time a block is written, and there's always written 512 bytes at a time, when the bootloader gets that 512 bytes, looks for the magic word, some magic number, and then looks at the address where it should be flashed, and then it flashes the 476 bytes. And here's the, pardon me. Here's the file format. Starts with UF2, and then, so it's kind of nice. You can even open up a file, and you'll see it says UF2, so you know it's a UF2 file. There's some flags, whatever. There's a magic number. So by doing this, they've kind of solved the problem. You never have to worry now about how an operating system does stuff with files. Like, for example, on Mac, if you drag the file over, the Mac file system will try to create, this trash file and this DB save file or whatever, and it'll get ignored because anything that doesn't start with this magic number just gets, the bootloader just ignores it. It just is like, well, whatever, I acknowledge it, you sent me this data, but I'm not going to actually save it. I'm looking only for data that has this special file format. So what's neat is it works really, really well. It's really reliable, never had any issues with it. Kind of solves the problem of this, every operating system is a little different. Chromebook is a little bit different than Debian, which is a little bit different, depending on what Linux version you have too. They changed the file system handling. Windows 7, Windows 10, all works. So check it out if you're interested. We also have a guide. Close all these windows. We have in our Feather M0 Express guide, we have a full page about the UF2 bootloader. So as a bonus, not only does the UF2 bootloader have have this cool mass storage thing, which I'll show in a moment, but it also is BOSA compatible, and that's the tool used in Arduino. So not only can you use this double click and then like drag a file over method to upload code, but you can also use it in the Arduino IDE, and it's just transparent. It looks just like the normal bootloader. They just squished it down enough that it shows up as both a disk drive and a serial port. So that's kind of neat. And maybe let's show a demo of it working. You want to maybe show on the overhead? So this is a Metro. It's plugged in only over here, but let's plug it into the computer. So right now it's running a little demo program that is like just does rainbow stuff, so I know it's working. To launch the bootloader into the UF2 or BOSA mode, you can do it manually by double clicking. And it actually has a little code for NeoPixels, so it sees that there's a NeoPixel here. It turns green, letting you know that the bootloader is successfully loaded. And then let's go to my combi. Let's see. Oh, sorry. Check this. So next on my computer, I have a new disk drive called Metro Boot. So that's the bootloader drive. And when you open it, there's 3 files. So there's info UF2, and this tells you the version. This is 1.21, model Metro M0. It tells you the board ID. It's just for debugging info. And it has an index.html file. If you double click on it, then the bootloader, you can tell it where it goes to. Right now it's going to the non-live page for the Metro M0, so it says preview. So it'll be 3505, so it's kind of nice. So if you plug it in, you run the bootloader, it'll launch the location where you can get more information about the product. It's kind of, I think, fun. Maybe it'll have information like, hey, here's how to download the latest version of Python or whatever. And then there's a current UF2. So current UF2 is actually the current flash. So you can read it if you want. So for example, if I want to make a backup of that like NeoPixel flashy code, I just drag it off, and now I've got this file here. And if I want, I can open it up, and you can see it starts with UF2. And you can see it kind of has these chunks, like, there's the magic word, and then the chunk, and then it says UF2 again. So it says every chunk is UF2, because again, it divides it up into 512 byte blocks. It's kind of nice, very easy, and very fast. You just took only a second to read the entire flash out. And then if I want to upload a new program, like for example, let's say I want to run CircuitPython. So we just did a build yesterday of CircuitPython for the Metro M0. I drag this file on, and sometimes it complains. It says, the disk drive ejected. Like if you have a Mac, it'll say, hey, you ejected the drive without warning, but that's okay. And then now, instead of the Metro boot folder, I have CircuitPy folder. So this is my CircuitPython code that I was working on earlier. So I can open up this code, and I was actually running, a little demo program here. I can wire up a NeoPixel to show it off. Can you go to the overhead? So I've got just a ring here, and my little demo program just swirls the ring around. Whoa, way too bright. So let's fix it. Let's go back to the computer. Instead of brightness 5, let's try brightness 1. And then again, with CircuitPython, you just save it and it automatically reloads it. So now when you go to the overhead, it's not nearly as bright. You can also make it a little bit brighter, maybe. And the NeoPixel tells you the status of CircuitPython. So you can see I can, very quickly update this. And we also have some other code that runs. For example, we have analog write and capacitive touch working, I2C scanning. For that sort of stuff, you'd want to open up the serial console. And let's say I'm like, so the one thing to watch out for is, there's 2 disk drives. There's the bootloader disk drive, which is like only, a couple K, and then there's the 2 megabyte disk drive where your Python code is stored. So let's say, I did all this CircuitPython code, but I'm like, well, I want to go back to that demo I had where it has just the NeoPixel running. So you can double click again to get back into bootloader mode. Just takes a second. Now it's in bootloader mode. disconnect my NeoPixel ring. Can you go to the Compy? And now, remember I had that backup I made? I'm going to drag that backup back on. It's going to say, hey, are you sure you want to replace the file? And I say, yep, copy and replace. And then when you go to the overhead, it's back to my little NeoPixel code. So that's how you do the backup and updating of files using UF2 bootloader. So it's really easy. Again, it runs on any SAMD processor, so I'm excited to maybe go back and make some older boards that we had come with this bootloader. And you can make your own binary files. Like the UF2 format, you know, there's a tool that they've made that you can take a hex file or a binary file and convert it into UF2. So for example, you know, let's say you want to have people use a Circuit Playground or a Metro or Feather and you want it to run Fermata, you could create a UF2 by running the tool on a binary that you've compiled and then distribute that around so that people can try it out. And then, like I said, it actually is also a BOSA compatible drive. So if I go to, let's open my my Blink sketch that I was using. So let's go to my computer. Let's say I wanted to upload this code, which is actually kind of the same code that's running right now. So let it compile. So you see the Metro boot shows up, but I'm actually using the serial interface, not the mass storage interface, but it still works and it uploads properly. Just looks like basically two devices. You know, you have a composite device with mass storage, and it also has serial. So works really well. I'm very excited. We found a couple bugs this week about the clock synchronization wasn't working quite right, but luckily we were able to fix it. And if you want to make your own UF2 bootloader, you can do so. The source code is available. You can go to GitHub, Microsoft UF2 SAMD, and all you have to do is make a new board format. So I've got a bunch here, but you can make your own. You can like copy the Feather one and modify it as necessary, and basically make your own UF2 bootloader. So if you have your own, maybe you're running it on a Zero or something, you can use your Arduino Zero or any other at SAMD based boards. You can use with this bootloader. It works quite well. That's kind of what I got. Just a small update, but it's a cool update. Are there any questions or people want to know stuff?
So I think it's pretty obvious, but it's worth emphasizing. Who wrote this bootloader? Is it open source? And where could you get it?
It's written by Microsoft. It is completely open source to the extent that they can open source their code. The Atmel source code that is included is not open source because Atmel is a lame. They don't use a truly open source license. It's free for use and it's available. It's MIT licensee, but it's for use with Atmel chips only. It's a thing that they put in. So it's a little. I don't want to say it's completely 100% open source because I think Stallman will appear and hit you over the head. But it is as open source as it can get. All of the files that they wrote are MIT licensed.
Shout out to Microsoft for doing this.
Yeah.
Excellent work on the SAMD.
Yeah. So this is the licensing. The Atmel code is Atmel code. All the original code is MIT. Anything else?
Could this be exposed to the internet like Samba so you could update it remotely?
Well, you'd have to get it into the bootloader state. That's the tough part. Like for this, you have to double click a button. But once it is a disk drive, yes, you could. It's just a disk drive. The computer doesn't know it from a USB key.
Next up, so would this work with the Feather?
Yeah, you can use it with your Feather. To get the bootloader onto your Feather, you're going to have to use a J-Link or something. That's the little bit of the challenge. Maybe you could use the update. Like it does give you a binary, and there's an update tool. You could see if uploading that updater, it might work. I don't know. A little mysterious. We'd have to use BOSA and then upload it, and then it would see if it works. I don't know. Yeah.
Could you expose the SPI chip when running off Arduino?
Yes, that's like the next thing we're going to work on is I wanted to get this bootloader stuff all solved. I'm still kind of hacking away at it. Because like I said, we shipped out a bunch of Feather M0s and 99% of them work, but we had like 1% failure rate and we're just figuring out why. And I think we've solved all of that. And then we're going to do more guides about how to use the SPI flash in Arduino. I mean, you can use it right now in Arduino, just it doesn't have a nice interface.
Does uploading Python code work on Linux and Mac, or do you get the same file system problems?
No, there's no file system problems. And the cool thing about Python is you only have to load it once. Once you've loaded the Python runtime, you never deal with the file system again. You're actually just like saving the code.py file. So the bootloader is only used when you have to get Python on for the first time, or you want to use it with Arduino or MakeCode.
Okay. Can you update the bootloader from the mass storage mode?
You can. When you create the UF2 bootloader, it creates an update file. I don't 100% recommend it. I haven't used it a bunch. Other people have. They say it works, but when you do the build, let's see, it is in atmel bootloader. When you do the build, it creates, for example, like here on Metro, it creates the bootloader bin file and also creates an update bootloader bin. In theory, if you load update bootloader bin onto your Feather or existing like Arduino Zero or something using BOSA, it ought to turn off the protection bits, write the bootloader to the bootloader location, and then lock it again. It's just a little bit risky because if something happens to go wrong, especially if you're like making your own bootloader and you maybe didn't compile it completely correctly or you got some pins wrong or something, it could, basically disable the current bootloader. You reverse the current bootloader, so you'd have to get a J-Link or like an SWD device to completely reflash it.
Okay. Could you go over what the failure was, and then how did you solve it?
The failure, for the bootloader? The failure was I was depending on some atmel code that does a thing called USB sync. So to save space and money on like the Circuit Playground M0 and the Trinket M0 and the Gem M0, which are not done yet, I don't put a crystal on. Instead, I use the internal oscillator, which is actually quite good. It's within 1% usually. And then when you plug it into USB, it synchronizes on the USB because the USB has a 1 kilohertz packet rate. And I was using some code from the atmel Samba bootloader, and I was kind of like, well, it looks like it works. And what I didn't realize is it wasn't actually synchronizing, but all of the dev boards I was using happened to have internal oscillators that were so good, like they were so precise, that they ended up being 48 megahertz, and so the synchronization didn't matter. Like it was just a thing where you don't notice until you have like 100 boards, because it was like 5 out of 100 were failing or something. So once, for development, I never noticed it. Like nobody ever noticed it because it was like, oh, sometimes it's a little flaky. Oh, like who knows? It was hand soldered. But then when we got to shipping out like 100 or 200, a couple customers actually, they started hitting it because their computer's USB ports just happened to be more sensitive to the frequency. And so that's when we basically looked at the clock output, we put it on the output on the pin, we realized like it was drifting quite a bit. Like I had one board that was like 36 megahertz. And the code in ASF that Scott was using was actually correct. So Scott actually did me a favor, and he's the one who figured out what was the correct code, ported it over, we compiled it, tested it, and determined that that was actually fixing the flakiness. And it fixed a couple flakiness with me. Like I had one Feather that it would work really well directly connected to my computer, but not well through a hub. So again, it was a clock synchronization, marginal error thing. But now we are synchronizing, and we're getting right on that 48 megahertz, like perfect phase lock loop. So if you're interested, you can see the latest commit in the UF2 code. You can see the fix we made. Not issues, commits. It's I don't know where oh yeah, here it is. So this is the clock commit. Basically, just setting the phase lock loop correctly. I don't know exactly what it was we were doing wrong. I can like look at the code, but basically just was not setting up the synchronization. Maybe it was enabling it. We definitely, the bits were being set, But maybe we didn't do it in the right order. And then when we moved to the ASF method of doing it, all things seem to work quite well. So that's good. Probably something like this. Like I didn't sync and then enable. You often have to like synchronize, then do a thing, and then synchronize again, then do another thing. If you don't synchronize every time, it works sometimes, it doesn't work sometimes. So flaky behavior. But luckily a lot of people in the forums were like 2 people were like, oh, they don't have this thing that's broken. We're like, yay, like time to have you debug with us. But when they updated the bootloader, it seemed to fix the problem, so that was good. Which is why we only do small runs when we start. We don't make 2,000. We make 100. See how that goes. Because if we have to replace 100, I'll do it. But I really don't want to replace 1,000 boards. That'd be kind of sad.
All right, that's it. Thank you, everyone. You can support Adafruit by going to adafruit.com, pick up some electronics and more. We're doing a bunch more Desktop Ladyadas. We have some citizen engineers planned. We're in the planning stages of some of that fun that eventually turned into Ask an Engineer, so it all worked out anyways. And check the Instagrams,
Yeah,
the
we're making the
tweets,
Metro M0. They'll be in the
the
store
Snapchats,
soon.
the Facebooks, and like, subscribe, share, and all that, and be excellent to one another. And don't forget, this internet invention only works if we all focus on one of the intents of it, which is to share information and be good. There's plenty of buy buttons and other things, but maybe our team can keep working on the sharing information and being good to each other part.
Yeah,
Yeah.
be
So-
good.
That's all I'm asking.
Make something interesting. Leave us a nice voicemail.
Yeah. All right. Good night, everybody.
All right, good night.